Hello, everyone. I wanted to revisit some things related to chemical nomenclature now that we know why that matters. And when I say that, what I mean is why now that we know why um, things are the way they are. So when we first went through this, a lot of the things about, say, the periodic table, the way metals behave, we kind of assumed things, and I said, okay, just kind of take it as a word that this is how things work. Now you know a little bit about why, so I want to revisit that because this will be a topic on the third exam. And again, you will not have the note card that you did on the first exam when you first saw this. And I want to look specifically at ionic compounds related to this. So we talked about, the process of naming these. In terms of balancing their charges. We'll see now why that works, and so we'll talk about that. We'll talk a bit about polyatomic ions. We don't have as much of a why there right now, but there are a few things that I think we can revisit now that will be helpful outside of the context of focusing on so many other things. So we'll revisit a few things there, and then especially we can talk about compounds that contain metal ions with a variable charge. That's something we can explain very well now. So let's go ahead and do that. So I'm actually going to go to the ionic and molecular compounds section to focus on some of these things. So you might remember we introduced this look at the periodic table, and at the time I said, okay, you're just going to have to kind of know some of these based on a pattern that seems very obvious here in terms of, okay, +1, +2, -1, -2, -3. And then all of these in here were kind of variable, and you didn't necessarily know what they were going to do. We can look at this now, and we can have a much better idea of what's going on. So we know that the metals will tend to lose electrons to resemble a noble gas. So if we lose 1, we'll resemble a noble gas. If we lose 2 here, we resemble a noble gas. And the nonmetals will gain electrons to resemble a noble gas. Okay, so we can now explain why these things were true that we were initially kind of accepting as true when we first introduced them. We can also explain this behavior in here because, at least somewhat, we can't explain necessarily all of it, but what we can for sure say is that the variable charges are because we now are looking at both S and D electrons, and there's a bit of an overlap, and sometimes you lose some of those, sometimes you lose more of those because of that. So it's not as simple in the transition metal region as it is in these first two groups. We could almost even predict, for example, why is zinc always a +2? We're not going to get to that level of detail for this class, but you could probably make a good case for why these things are specifically what they are. For example, iron +2 and +3, based on the knowledge that you have. Again, a bit deeper than we need to get for this class. And then we can also talk a bit about the polyatomic ions. So again, you will not have the note cards that you had on the previous exam. So you're going to kind of need to know some of these for the third exam. But what I want to do is I want to talk about this in a way that helps focus it on what you will need. And that involves looking at some trends here. So you're not going to need all of these, but we can look at some trends here. And it actually talks about that down here. So one of the trends is between when we have the ATE ending and the ITE ending. And it turns out the trend is not always the same. For example, chlorate has 3 oxygens, and phosphate has 4 oxygens. So it's not exactly each time you have this ending, you have this many oxygens, and the charge you can also see is different. From chlorate is a -1 charge, phosphate is a -3. But what they mean is the one that ends with ATE is the most common. So chlorate is more common than chlorite. The difference is then the number of oxygens. So if you remember the one that ends with ATE, the one that ends in ITE is just a little bit different than that. So ATE is 3 oxygens minus 1 charge. Chlorite is 2 oxygens minus 1 charge. So the only difference between those is the number of oxygens. ATE has 1 more oxygen than ITE, and that's always going to be the case. The charges will always be the same. So you don't have to memorize chlorate, just memorize chlorate, and then chloride is 1 less oxygen. We have this additional trend that sometimes comes up. Not everything will have this, so there's not, for example, a hyponitrate. But if you have even 1 fewer oxygen, then you have the hypo prefix. So hypochlorite has only, so instead of 2, it has only 1 oxygen. So we have the hypo prefix to show that. And then if you have even 1 more than the AT ending, then we have a prefix of per. So perchlorate has 4 oxygens, where chlorate had 3 oxygens. The main place you'll see this is actually just with the chloride-based oxyanions. And there aren't any others you would need to know with the per and the hypo, but there are a lot with the prefixes at ATE and ITE. So we see that show up with sulfate, SO4 2 minus, sulfite, SO3 2 minus. So again, only difference is the number of oxygens. You will notice here though that the charge is different than it was for the chlorate. Also, the number of oxygens is different than it was for the chlorate. We see nitrate, nitrite. Again, 3 and then 2, -1 charges there. We don't have a carbonite, we have a carbonate, and we have a phosphate. So there will be, I think actually the best way to do this is I'll have an amended table to the one we're seeing here in the review for Exam 3 PowerPoint that shows these are the ones that you should know. It won't be everything on this list, but it will be a subset of these examples. So in terms of the nomenclature, we will be revisiting nomenclature for ionic compounds because we know a lot more now in terms of why things are the way they are. So that is kind of a little segue in our current module. We're going back and revisiting a few things.